breakthrough project. In this video, we are going to explain about a project titled Lung Cancer Detection and Classification based on AlexNEt CNN and ML. Lung cancer, a prevalent and highly lethal cancer type globally, demands timely detection and precise categorization for enhancing the patient prognosis and guiding the effective treatment strategies. Recent years have witnessed the significant strides in the realm of deep learning and the machine learning, offering the promising avenue for the medical image analysis, particularly within the cancer detection and the classification domain. This study introduced an innovative approach to identify and classify the lung cancer. This method entails a hybrid model that the use of AlexNEt CNN with the convolutional machine learning algorithms. Notably recognized for the image classification, AlexNEt fusion with the traditional machine learning empowers to harness the deep learning feature extraction proficiency alongside the interpretability inherent to the conventional machine learning model. This synergy strives to foster the accuracy and interpretable insights for detecting and characterizing the lung cancer, thus contributing to the refined clinical decision making. Presented thus an innovative approach to differentiate between the malignant and benign lung tumors employing a CNN-based AlexNEt model. This method endeavors to enhance the precision of diagnosing and treating the lung cancer. It has posed the substantial difficulty for the medical professional in recent years. By enabling the early identification of lung cancer, the proposed technique holds the potential to rescue a substantial number of lives globally on a day-to-day basis. The integration of cutting-edge deep learning techniques like CNN, particularly utilizing brain-bonded AlexNEt architecture, underscores the commitment to advancing the medical diagnostics and signifies a pivotal step towards bridging the gap in lung cancer detection accuracy. And these are the basic requirements that are needed to build this project. The software requirements are Python IDE with version of 3.7, Anaconda with version of 3.7 or Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the package. This project begins by importing the necessary packages and libraries, laying the foundation for the lung cancer detection and classification using the different machine learning and the deep learning models. And the next one is exploring the dataset. The dataset containing the lung tumor images is explored, providing the insight into the available data for the model training and validation. And the next step is image processing. Images undergo pre-processing procedure which encompass resizing, normalization, and noise reduction, preparing for the subsequent analysis. And the next step is extracting the image to train and the test. Images are extracted from the dataset to create the separate sets for training and the testing. These sets are processed and converted into the number arrays for the compatibility with the model. And the next one is the data visualization. Here, visualization techniques are employed to gain the visual understanding of the dataset characteristics and the distribution. This step aids in identifying the potential patterns or disabilities. And the next step is flatten and shuffle the train and the test data. The image data is flattened and shuffled to ensure the randomness and prevent bias during the training and the testing stage. And the next step is building the model. Here various models are built. The first one is AlexNEt. It is a pioneering deep convolutional neural network architecture specifically designed for the image classification task. It features the multiple convolutional layers, max pooling layers, and the fully connected layers. AlexNEt gained the prominence for its victory in the ImageNet large-scale visual recognition, showing its ability to extract the intricate feature for the image. In the context of the lung cancer detection and classification, its feature extraction capability contribute to the accurate tumor characterization by training the network on the lung tumor images. And the next one is CNN. A CNN is a class of deep learning model tailored for the image classification task. It consists of layers like convolutional pooling and the fully connected layers, enabling it to learn the hierarchical features from the images. In the lung cancer detection, a CNN can discern the complex pattern present in the tumor images by training on the labeled dataset. The network adopts its internal weights to accurately differentiate between the malignant and benign tumors. And the next one is full CNN. It's an extended version of the standard CNN architecture and with additional convolutional and fully connected layers. This heightened the depth enables it to comprehend the more intricate features and the relationship within the images. In lung cancer classification, a full CNN increased complexity offers the potential for more nuanced understanding of tumor pattern. And the next one is MobileNet. It's a lightweight CNN architecture designed to be efficient, and it employs adaptive separable convolution to reduce the computation while maintaining performance. In the lung cancer context, MobileNet efficiency is advantageous for real-time analysis. Its rapid inference speed ensures the quick response to the user queries, allowing the medical practitioners to promptly assess the tumor images. And the next one is MobileNet plus AlexNEt. A fusion of MobileNet and AlexNET levers the strength of both architectures. Its efficiency complements the AlexNET feature extraction prowess. This hybrid model seeks to strike a balance between the accuracy and speed in the lung cancer detection, especially suitable for applications requiring the timely diagnosis as it combines the accurate feature identification with the efficient computation. And the next one is SVM, stands for Support Vector Mission. As a traditional machine learning algorithm, the Excel and the binary classification task. In the lung cancer detection, it analyzes the image features and establishes a decision boundary to classify the tumor by identifying the key discriminative feature. It contributes to accurate the tumor characterization. It lack of ability to capture the intricate visual pattern the deep learning architectures like CNN offer. And the next one is voting classifier. It combines the prediction from the multiple individual classifiers such as random forest, decision tree, and support vector mission through a voting mechanism. This ensemble approach harnesses the diversity of different models, enhancing the overall classification accuracy. And the context of the lung cancer classification, this hybrid approach seeks to mitigate the weakness of individual models and yield a more robust and accurate prediction. And the next step is user uploads an image for analysis. Here we build a class is a web interface where the user can upload the image for the analysis. And the next one is the given input image is pre-processed. When a user uploads an image, the system pre-processes it involves a necessary processing step to align it with the model requirement. And the next step is trained model is used for predicting the result. The trained model determined during the building phase is deployed to predict whether the input image represents a malignant or benign lung tumor. And the next one is final outcome is displayed. The culmination of process involves presenting the final result to the user. This involves displaying the predicted classification alongside the input image, providing the valuable insight into the potential nature of the lung tumor. And the execution of the project, to execute the project, first we need to open the code folder. And this is the code folder containing of various files within it, the sample folder containing of the images that will be used to test the performance of the model, and the static folder containing of the folders like images, uploads, assets, CSS, JavaScript folders within it. And the template folder containing of the HTML documents typically include of home, index, result sign-in and sign-up pages within it. And the app is an py file which contains the information related to the front-end logic. It includes the code written in Python that handles the server-side operations such as processing the user request, interacting with the database, and generating the dynamic operations that to be rendered in the HTML template. And this is the dataset containing of the testing and training of containing the various images within of each of the case like benign, malignant, and normal. And the model is a pickle file which contains the algorithm information and loaded into the project code during the runtime to utilize the trained model for the various tasks, such as making the prediction on the new data or performing the specific operation. And the notebook is an IPYNB file which contains the combination of code, graph, and output all in one place. It allows the user to write and execute the code in the individual cell, making it a popular choice for the data science. And the signup.db is a file appeared to be the database file used to store the user information. And these are the MPY files of the testing and the training of the dataset. And for the execution of the project, first we need to copy this code folder path and then open the Anaconda prompt. Here we need to write a command that is cd space and paste this code folder path. By this, it will change the current directory to the code folder path and then click on the enter button. Here we need to write a command that is python space app.py. By using this command, it will execute the Python script and perform the runtime check for any syntax errors or logical issues. And then click on the enter button. After running this app.py file, the Flash framework will host the application locally at the default address like this. We need to copy this link and paste it on any of the web browser of our choice, and I prefer to use the Google Chrome. I'm pasting this link and then click on the enter button. Here we can see the title and some information about it, and then click on the sign up button. Here it will redirect to the sign up page containing of some necessary details that need to be filled to create an account. But my account is already created, that's why I'm using the sign in button. Here it will redirect to the sign in page containing of the username and password. And I'm filling those details and then clicking on the login button. And here it redirected to this page containing of the choose file and upload buttons. And here I'm clicking on the choose file button. It redirects to this folder containing of the various images within it. I'm selecting one and then click on open button and then click on the upload button. Here in this case, it predicted the result as of the normal stage. And by clicking on the try again button, we redirected to this index page containing of choose file and upload buttons. Then click on the choose file button and select any one of the image and then click on the open button and then click on the upload button. Here at this predicted image of the uploaded one is image based on the threshold is like of 1, and after the morphology it is a segmented image, and the final image with countdowns is of like this, and the final output the patient is diagnosis with Bengen stage. In this way we can diagnose the stage of the lung cancer of a patient by using the various deep learning algorithms. And by clicking on the try again button, here redirected to this page, and by clicking on the choose file button and select any one of this image and then click on the open button and then click on the upload button. Here it redirected to the result page and predicted the uploaded image as having this is the segmented image based on the morphology, and it is full image of final one of countdowns, and the result is diagnosed with malignant. In this way, we can diagnose the lung cancer of a patient by using the various deep learning algorithms. And in conclusion, the proposed hybrid approach for the lung cancer detection and the classification, combining the deep learning capability of the AlexNEt CNN and the traditional machine learning algorithms. The result obtained from our experiment demonstrate the effectiveness and the potential of this hybrid model. Our model achieved the high accuracy and off-box scores and detecting and classifying the lung cancer based on the deep features extracted by AlexNEt. Moreover, the interpretability of the machine learning algorithms allowed us to gain the insight into the decision-making process and better understanding the underlying pattern in the images.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.